Alright, so today we are finding the inverse to exponential and log functions. Today is the first day of this topic, so whenever we're finding exponential and log function inverses, we're going to do it the same way that we do all of our inverse functions, where we find our x and our y and we flip them and we solve for y. So just like the last video, I am going to be doing the evens because these are the more difficult problems in my opinion. So we're just switching our x and our y. And remember, we're solving for y. So I'm going to add this one over. Now if this was x minus 1 in parentheses, we could not separate it. Since it doesn't have parentheses, then we can separate it. So now we've got a log is equal to something, so we can convert to get that y by itself. So 3 to the power of x plus 1 is equal to y, so my inverse function is 3 to the power of x plus 1. So we see that the inverse to that log was an exponential. Now in number 4, we've got x squared in there. So we're going to do it the same way by switching the x and the y. I am going to use the properties that I know, and I'm going to bring down that squared as a coefficient on the log. Divide both sides by 2. X over 2 equals log base 4 of y. Then I'm going to convert. So 4 to the power of x over 2 is equal to y. X over 2 is a 1/2 power. A 1/2 power is going to be a square root function. Remember, with our rational exponents, so our exponents that are fractions, the top is the index, bottom is the index. So it's power over index. So my index is 2, and my power is x. So the same thing on number 6. We're going to bring down that 2 and switch the x and the y. Divide by 2. And then convert. So 6 to the power of x over 2 is equal to y. And then, just like the last one, we're going to write it with the index as 2 and the power as x. Number 8, we start by switching x and y. We want to get that y by itself. We're going to convert. So we have the base of 5 to the power of x is equal to y plus 1. Subtract 1. 5 to the power of x minus 1 is equal to y. Now when you're writing these, you need to make sure that I can tell where that minus 1 is, whether it's in the exponent or it's in the problem without the exponent. So just make sure that I can tell where it is, because it's going to change your answer. Now number 10, same thing. Oops. So we want to make that a y plus 9. And then nothing can be moved first since we have those parentheses. So we will convert to the x is equal to y plus 9. Subtract the 9, we get 2 to the x minus 9 is equal to y. X equals log base 6 of y minus 6. We're solving for y, so we'll convert 6 to the power of x is equal to y minus 6. Add 6. 6 to the power of x plus 6 is equal to y. Now number 14, we have a power in there, so we're going to bring it down as a coefficient. And we'll divide it out. And now we can convert, so we get 6 to the power of x over 4 is equal to, you should be wise, sorry, there we go, is equal to y. And remember it's power over index, so we have a 4th root of 6 to the power of x as my function. And we'll go to the right side on the second page. X equals log base 4 of 3 to the power of y. X equals y log base 4 of 3. And remember our logs are just a number, so I'm going to divide by log base 4 of 3 to get y by itself. So we get x over log base 4 of 3 is equal to y. X equals y log 2 of 6. So we brought this down and we switched x and y. Divide out that number. And our inverse function is y equals x divided by log base 2 of 6. Now in number 20, we have this function y equals negative 3 to the x over 3. So what we want to do here, of course, is switch our x's and our y's. And I want to get that y down. So what I'm going to do is multiply by a negative 3 on both sides. So I get negative 3x is equal to 3 to the power of y. So this canceled this and the negative. And then I'm going to be able to convert. This is my base. So log base 3 of negative 3x is equal to y. (22), the same deal, where we have a fraction so we've got x equals negative 6 to the power of y over 3. So we're going to multiply again by a negative 3. And then we'll convert. So log base 6 of negative 3x is equal to y. Now on number 24, we're going to switch our x's and our y's first. and I want that y to be in my numerator. So whenever I move across a fraction bar, my exponent has to change sign. And we know that from Algebra 1, but it might be something that we've kind of forgotten about. So this is the same thing as 3 to the negative y power over 4. Now I don't want that 4 on the bottom there, so I'm going to multiply both sides by 4. So I get 4x is equal to 3 to the negative y power. And then I'm going to convert. This is my first, my last, and my middle. So we get log base 3 of 4x is equal to negative y. And I want y to be positive, so I'm going to change every single sign. And so I get positive y equals negative log 3 of 4x. Since the 4x is inside parentheses and belongs to that log, we don't put the negative inside the parentheses as well, we just leave it. And on number 26, switch our x and our y, and convert first, last, and middle. Remember, the base of either our exponents or the base of our logs is always going to be the base. So that should be your marker of where first goes, last goes next to it, and then middle's on the other side always. So log base 10 of x is equal to y divided by 4. We'll multiply by 4. And then we can change that to an exponent if we want to. So this is log base 10 of x to the 4th is our inverse function there. And then the same idea on 28. We got x equals 6 to the power of y over 4. When we switch them, my base is always my base, first, last, middle. Log base 6 of x equals y over 4. Multiply by 4. 4 log base 6 of x is equal to y. And then I'm going to change that 4 to an exponent. Log base 6 of x to the 4th is equal to y. So then that is the right side, the evens on this worksheet, and then for your homework you'll be doing the odd side, so everything on the left, and then you'll just turn it on canvas, and I'll see you guys in the next one.